Hello everyone, welcome back to Apti. This is part 2 of our clock series. In this video, we will dive into an important and interesting concept, time gain and time loss question. These types of problems are commonly asked in competitive exams like SSC, banking, railways, and are also frequently seen in placement exams of top companies like TCS and Wipro. Before watching this video, make sure you have watched the part 1 of this series where I have discussed finding the basic clock angles, the time at which the hands of clock coincide or are in opposite direction, and the mirror image time, also some direct formula based questions. So let's start with our today's topic. The topic is time gain and time loss. So if in the question it is mentioned that a clock gain 5 minutes in an hour, this means that if a normal clock is showing time as 8 o'clock, so after 1 hour the clock would show the time as 9 9 o'clock. But this clock is gaining 5 minutes in an hour. So this clock will show the time as 9:05 instead of 9 o'clock. Again, after 1 hour, the normal clock would show the time as 10 o'clock. But this clock, as it is gaining 5 minutes, it will show the time as 10:10. Similarly, after 1 hour, the normal clock would show 11 o'clock, but this clock will show the time as 11:15 and so on. Now again, if it is said that a clock loses 5 minutes in an hour, this means if the normal clock shows time as 8 o'clock, so after 1 hour, the normal clock would show 9 o'clock. But this particular clock, as it is losing 5 minutes in an hour, it will show the time as 8:55. Again, after 1 hour, the normal clock would show the time as 10 o'clock. But this clock will show you the time as 9:50 and so on. Now this topic doesn't has any particular formula that so that you can solve this question. These are totally logical based, and if you try to understand the logic behind it, you can easily solve these questions. So let's start with our first question. The question states that a clock was set right at 8 a.m. The clock gains 5 minutes in an hour. What time it will be at 8 p.m. on the same day? So now let's try to find out the total hours. The clock starts at 8 a.m. and we have to find the time when the clock reaches 8 p.m. So this total has 12 hours of gap. But in the question it is said that the clock gains 5 minutes in an hour. So in 1 hour the clock is gaining 5 minutes. So in 12 hours, how much time or minutes will it gain? So just cross multiply, we get it as 12 into 5 as 60 minutes, which is 1 hour. So the clock normally was showing 8 p.m. But we found out that the clock has gained this 1 hour. So instead of showing the time as 8 p.m., the clock will show time as 9 p.m. So it is option B. Now let's read the second question. A clock is set right at 5 p. A clock is set right at 5 a.m. The clock loses 16 minutes in 24 hours. What will be the true time when the clock indicates 10 p.m. on the fourth day? Now we have to find out the correct time or the true time which a normal clock was showing, which means the 10 p.m. on the fourth day is the false time when the clock is losing 16 minutes. So let's find out the total hours. So it is 5 a.m. on the first day, then 5 a.m. on the second day, 5 a.m. on the third day, and then again 5 a.m. on the fourth day, and 10 p.m. on the fourth day. So this are 24 hours, again 24 hours, this is 24 hours, and this is 17 hours of difference. So if we find out the total, the difference is of 89 hours. Now in the question it is stated that the clock loses 16 minutes in 24 hours. So in 24 hours the clock is losing 16 minutes. So in 89 hours how much time will it lose? So just apply the unitary method and cross multiply. We get 89 into 16 divided by 24. Now if you calculate it, you will get some decimal values of 59.33, which you can assume it as 60 minutes, which is nothing but 1 hour. Now the false clock was showing time as 10 p.m., which means after losing this 1 hour of time, the clock was showing the time as 10 p.m. But a normal clock would show the time as 10 plus 1 this hour. It will show the time as 11 p.m., which is option A. The third question states, a digital wristwatch was set accurate at 8:30 a.m. and then lost 2 seconds every 5 minutes. What was the time indicated at 8:30 p.m. same day? Let's find out the total hours. So the clock starts at 8:30 a.m. and it was stopped at 6:30 p.m. So this total is a difference of 12 hours. Now in the question we have been given that the clock is losing 2 seconds every 5 minutes. So in 5 minutes the clock is losing 2 seconds. Let's convert this 10 hours into minutes. We get it as 10 into 60, which is 600 minutes. So in 600 minutes, how many seconds would it lose? Apply the unitary method. It is 600 into 2 by 5. We get it as 240 seconds, which is nothing but 4 minutes. You can divide this as 240 by 60. You get it as 4 minutes. Now the clock has lost the time. So the correct time it was supposed to show was 6:30 p.m. But it is losing this 4 minutes. So the time it would show will be 6:26 p.m. The correct option is option B. Let's look at next question. A clock loses 5 minutes for every hour and another gains 5 minutes every hour. If they are set correct at 10 a.m. Monday, then when will they be 12 hours apart? So in this question, there are two clocks given to us. One is losing 5 minutes every hour and the another one is gaining 5 minutes every hour. So let's see what can be the cases of our time. Let this be our normal clock. Then the second is clock 1, which is losing 5 minutes. Then we have clock 2, which is gaining 5 minutes. So initially both the clocks were set at 10 a.m. So our assumed normal clock would also show the time as 10 a.m. Now after 1 hour, the normal clock would show the time as 11 a.m. The first clock will show the time as 10:55 as it is losing 5 minutes. And the second clock would show the time as 11:05 as it is gaining 5 minutes. Now again after 1 hour the time will be 12 a.m. The clock one would show the time as 11:50 a.m. and the clock 2 would show the time as 12:10 a.m. Again after 1 hour, this was supposed to be 12 p.m. the clock 1 would show the time as 12:45 p.m. and the clock 2 would show the time as 1:15 p.m. Again, after 1 hour, the clock 1 would show the time as 1:40 p.m. Clock 2 will show the time as 2:20 p.m. Now at 3 o'clock, 1 will show time as 2:35 p.m. This clock would show time as 3:25 p.m. Again at 4 o'clock, the clock 1 will show the time as 3:30, while clock 2 will show the time as 4:30. Now if we look at the difference between clock 1 and clock 2, initially it was 0. After 1 hour the difference is of 10 minutes. Then after another 1 hour the difference is of 20 minutes. Then the difference is, this is 45 and 115, so the difference would be 30 minutes. And similarly it is 40 minutes, 50 minutes and 60 minutes, which is 1 hour. So when the normal clock is covering 6 hours, the clock 1 and clock 2 will have a difference of 1 hour in them, which means after 6 hours the difference between clock 1 and clock 2 will be 1 hour. So after 6 hours there is 1 hour of difference. So after how many hours will the difference be? 12 hours. So we can solve it as, it becomes 6 into 12 as 72 hours. So let's convert it into days. So 24 hours is 1 day, which means 72 hours is 3 days. The clock started at 10 a.m. on the Monday. So 3 days after Monday is Thursday, which means the correct option is 10 a.m. on Thursday. The fifth question states that the minute hand of a clock overtakes the hour hand at an interval of 66 minutes of correct time. How much in a day does the clock gain or lose? So there is a small concept which we need to learn before going through this question. The concept is that in 1 hour the minute hand travels 60 minutes, or we can say that it travels 60 minute spaces, and in 1 hour the hour hand covers a distance of 5 minutes or 5 minute spaces. Now how much more is the minute hand traveling? It is 60 minus 5, which is 55. So we can say that minute hand gains 55 minute spaces over the hour hand in 1 hour. The minute hand gains 55 minute spaces over the hour hand in 1 hour. So it is gaining 55 minutes in 1 hour, which is nothing but 60 minutes. So in how much time will it gain 60 minute spaces? So in 60 minute spaces the gain is, it is 60 into 60 divided by 55. So if you solve this, you get it as 720 by 11, and you can just write it as 65 5 by 11. Now coming to the question is stating that the clock is gaining 65 minutes spaces, but we just found out that it was supposed to gain 65 5 by 11 minutes spaces, which means it is gaining more time than it was supposed to. So let's find out how much more it is gaining. So it is 66 minus 65 5 by 11. Now you can write it as, if you find out the difference, you get it as 1 minus 5 by 11, which is nothing but 6 by 11. So the clock is gaining this 6 by 11 time more, and it is gaining this in 66 minutes. So in 66 minutes, it is gaining 6 by 11. So in 1 minute, how much time will it gain? So it will gain 66 into 11, which you get it as 1 by 121. Now we have to find out how much in a day does the clock gain or lose. So in a day, how many minutes we have? We have 24 into 60, which is 1440 minutes. So in 1 minute, it was gaining 1 by 121 minutes. So in 1440, how many minutes will it gain? So just multiply it, 440 into 1 by 121, and if you solve this, you get it as 11,109 upon 121 minutes, which is option C. The last question for today. A clock which gains uniformly is 5 minutes slow at 8 o'clock in the morning on Sunday, and it is 5 minutes 48 seconds fast at 8 p.m. on the following Sunday. When was it correct? So as per the question, it is given that a clock started at 8 a.m. and it was Sunday, and the last time that we have been given is 8 p.m. but it is on the next Sunday. When it started on 8 a.m. Sunday, it was 5 minutes slow, and when the 8 p.m. And when the time was 8 p.m. on the following Sunday, it was 5 minutes 48 seconds faster. Let's find out the total hours from 8 a.m. Sunday to 8 p.m. the next Sunday. So it is a gap of 7 days. So it is 24 into 7, and plus this 12 hour from 8 a.m. to 8 p.m. So we get the total hours as this becomes 168 plus 12, it is 180 hours. Now we have to find out when was the clock showing the correct time. So there will be a point of time between this time frame when the clock will be showing a correct time. So the clock was 5 minutes slower when it started, and when it stopped, it was 5 minutes 48 seconds faster. So how much it is gaining? It is gaining total of this 5 minutes and this 5 minutes 48 seconds. So the total gain is of 5 minutes plus 5 minutes 48 seconds. So the total gain is of 10 minutes 48 seconds. But to show the correct time, the clock just has to gain over this 5 minutes difference of time. So when the clock will gain this 5 minutes, it will show a correct time, and after showing correct time, it will again gradually start by going faster, and after it reaches 8 p.m. on the Sunday, the time it will show will be 5 minutes 48 seconds more. So in 180 hours, the clock has gained total of 10 minutes 48 seconds. So how many hours does it need to gain over this 5 minutes? Okay. So you can write this 10 minutes 48 second as 10 and 48 by 60. This is 12 fours are 5 are, and you get it as 54 by 5 minutes. So this 10 minutes 48 seconds can be written as 54 by 5. So if we find out this number of hours, we can write it as 180 into 5, and this will come over here, and we will write it as 5 divided by 54, and if you solve this is 18 tens are, this is 18 threes are, it becomes 250 by 3, which you can write it as 83 1 by 3, and this 1 by 3 can be written as 83 and 20 by 60. Just multiply by 20 both in both numerator and denominator, and you can write it as 83 hours and 20 minutes. So to cover the distance of 5 minutes, which means to gain 5 minutes, it requires 83 hours 20 minutes. But we have to find out the exact time and the day. Now 83 hours, your 24 hours completes one day. So 83 hours 20 minutes would be it would be 3 days and plus 11 hours and this 20 minutes. Now the clock was starting at 8 a.m. on the Sunday. So 3 days after would be Wednesday. So at this would be 8 a.m. on Wednesday. We have to add again this 11 hours and 20 minutes. So it would be 7:20 p.m. on Wednesday. So the correct option is option B. That's it for time gain and time loss problem. I hope you understood the concept. If you found this helpful, give it a thumbs up and share it with your friends preparing for placements or government exams. And don't forget to subscribe to Apti for more such tricks and exam focused concepts. Thank you for watching.